Good morning, everyone. So what I thought we'd do today is take a pause and kind of do a review on everything that we've done so far. So the two big ideas from this unit is solving inequalities as well as solving absolute value equations. So before we move on, I want to get a solid understanding on that, as well as do a little bit of a review on some older material that we've talked about. All right, let's go ahead and move forward. Oh no, don't come up here, kitty. Yeah. Yeah. There we go. No, you can't come up here. No. Hey. All right, so let's go ahead and take a look at our first problem. So we have 2 minus 3x less than or equal to 5. Go ahead and solve that. And when you're ready, we'll move on. All right, so just like in the past, we're going to solve this like a regular equation. Did you remember to bring down the -3? Common mistake. All right, so divide by -3, so x equals -1. We're going to put the -1 on the number line. So my final answer should be like this, x something -1. So the way I determine what it is, I've got to test a point. 0 sits over here. So I'm going to plug 0 into there. 2 minus 3 times 0. I'm going to ask myself, is 2 less than 5? Yes, it is. That's true. So this is the direction I'm going to shape. So my sign is going to go in this direction. All right, let's try the next one. 5 less than x plus 3. All right, let's check our answer. We're going to write 5 equals x plus 3 minus 3 from both sides. So x equals 2. Again, that's going to go on my number line. In fact, I can already put this in my final answer box. I'm going to test a point. So I'm going to test 0. So is 5 less than 0 plus 3? No, that's false. So I'm going to go in this direction, which means I'm going to go this way. Notice that because there's no bar or equal sign, that's an open dot, which means there's no equal sign here. All right. All right, let's try another one. All right, let's check our answer. So I'm going to write as an equation, distribute. All right, minus 5 from both sides, I'm just going to be left with this. Uh-oh, that's not, I lost all my variables, so that's a problem. So the question is, I'm going to go ahead and put this all back together. I'm just going to make this less than or equal to, less than or equal to, less than or equal to. Here's the question, is 5 less than or equal to 2? The answer is no. So then, since the answer is no, since this is false, this is no solution. Right? If it were true, then I'd write all real numbers. All right, number 4. We have 2x plus 3 greater than 3. All right, let's go ahead and check our answer. Now, this is okay. I'm allowed to have a 0 here. See the difference between the two? This one, all my letters disappeared, my variable disappeared. This one, I still have a variable in here. So I can continue solving for that variable. That's just going to be 0. So now I'm back to drawing my number line, putting my value in, and putting my 0 in. And I've got to determine which way the sign goes. So I'm going to put 0 here. and it's going to be an open dot. Now the problem is I can't test 0, so I'm going to test another point. I'm going to test 1. So I'm going to plug 1 in for x, and then still I'm going to ask myself the question, is 5 greater than 3? Yes, it is. So this is the direction I'm going to shade in. So that's the direction of my inequality. So what this says, just as a reminder, it means all the numbers that make this expression true or this inequality true has to be greater than 0. So all my answers are greater than 0. So 1 will work, 2 will work, 3 will work, 0.5 will work. All right? All right, now let's go towards the stuff that we just talked about on Monday. So the absolute values. So let's go ahead and take a look at that one. All right, go ahead and try that. So remember, what's underneath my finger has to have 2 answers. It has to be 6 or negative 6. So we have 2x plus 1 equals 6. 2x plus 1 equals negative 6. And I'm going to subtract 1 from both sides. So 2x equals 5, or x equals 5 halves. I'm going to subtract 1, so 2x equals negative 7, or x equals negative 7 halves. All right, so notice what's becoming negative. This is going to be negative 6, or this is going to be 6. All right, number 6. All right, go ahead and try that one. Same thing. I'm going to write whatever's under my finger, and I'm going to write 7 or negative 7. So 3x minus 2 equals 7. 3x minus 2 equals negative 7. Add 2 to both sides. Divide by 3. Add 2 to both sides. So x equals negative 5/3. All right, hopefully we're getting the hang of it. All right, number 7. All right, so this one was a little bit trickier. Some of us are probably getting into the habit of saying, oh, this has got to be 2 or this has got to be negative 2. But pause for a second. What does this mean? It means there's some number I'm going to stick in here that when I take the absolute value, it'll give me negative 2. Is there a number you can think of that will give me a negative 2? Well, if you said negative 2, that won't work because the absolute value of negative 2 is 2. In fact, the absolute value of 2 is 2, so that won't work either. So by definition, an absolute value, what it does is it takes the positive value of that. Therefore, there's nothing that's going to work. All right, so this one would be no solution. All right, number 8. And this is our last one. All right. So on this one, you have to do something first. You have to get rid of that 1. So we have to isolate the absolute value sign. I'm going to add 1 to both sides. So that's going to be 7. Oops, sorry. All right. So if you didn't do that first and go ahead and solve it real fast. All right. So now we have x plus 2 equals 7. X plus 2 equals negative 7. And now we can finish solving this. So x equals 5 and x equals negative 9. All right, so hopefully that reviewed a little bit of what we were doing. What I'm going to do is I'm going to also throw in a little bit of a preview for what's going to come ahead, and just to kind of plant the seed. This would have been a warm-up for the day. Could you graph this? Just do a quick sketch. Yeah, do you remember where we started? We start at 1, that's our head start. And then we go up 2, right? Our slope was up 2 over 1. And here's our sketch. And if you can kind of guess where we might be going, I might be changing that sign pretty soon. All right. All right, try one more. Let's make sure we're good. All right. So you should have gotten 3 and then go down 3, 1, 2, 3 over 2. And back to this. All right, so hopefully that brings back some memories. And then what we'll do is we'll move forward from there. All right, what I'd like to do next is just kind of do a review on a couple of things that we've done from first semester that's going to come up again in this unit. And it's going to be graphing. So something like this, y equals 2/3 x minus 1. Remember how to graph it? Where do we start? Hope you said -1. And then where do we go from there? Up 2 over 3, that's correct. And then we just connect the two dots, right? But what if it looked like this? Well, this one's not bad. I can just solve for y and graph it like that. But I don't know if you remember, I could always go back to a table, and this might be helpful in some situations. I can just find the x and y intercept, right? If I wanted to find the x-intercept, I make y equal to 0. So if y is 0, you could just cover up this y, that's 0, oops, knock the camera. This becomes 0. So x has to be what? 3. Right? So then I know my x-intercept is 3. And then if I want to find my y-intercept, I'm going to make x 0. So if x is 0, this will go away. And what does y equal? 6. 1, 2, 3, 4, 5, 6. And we have a line going down. So just 2 ways of graphing I just wanted to throw out there just as a memory from before, because we are going to go in this direction. And in fact, what we're going to start to see later on is we're probably going to change this symbol. I'm sure you could guess what's going to happen. All right. Have a great day. Make sure if you have any questions, you do ask. All right. See you later.